It can happen at stage 7 and 8. And it can happen at stage 2 to 3. So, programmed cell death, PCD. So those stages will start popping. And you'll start killing off those embryos. So you don't hurt the germaria. The germaria or the stem cells stay put and they can keep actively dividing. Those stay fine. But essentially you're shutting down the conveyor belt. When this happens, you also go from this nice big fluffy ovary set to something like this. It reabsorbs those stages. Yep. It uses the nutrients it normally would have gotten and pulls them right back in. Yep. And so you can see it physically on the ovaries too. You go from the really big fluffy ovaries, so this is healthy to starved. And what's really cool is if you start feeding them in 24 hours, they'll go right back. They'll go right back and make it big again, the ovaries. And after 24 hours, if high fed, it'll shut off those pathways that causes the apoptosis. Yep, exactly. The recovery period is remarkably fast, which makes sense because remember, in the wild, normally they only live 2 weeks, roughly. And so you don't have the time to take, a week to reset your ovaries based on what you're feeding, right? So you need to have a fast turnaround for shutdown and for turning back on. And so the reason we know this individual here is healthy because the abdomen is very large, meaning that she's laying, she's able to lay a lot of eggs. If the abdomen was collapsed and thin, then there would be a lot of this apoptosis activity happening in the ovary. Pretty gnarly way of doing this. And there's a whole signaling cascade that happens. There's, if we really want to get into it, there's in the brain and in the brain, there's signals that are sent to the ovary to keep them on or off too. And in part of that is how much is being fed, but then there's other neuronal cues that are acting on it too. So there's the insulin signaling pathway that's like known to hit these stages, but then there's other predator threats that can also trigger it. They can also put their eggs into a state of dipause, which means cellular arrest. Basically puts everything on pause. So instead of killing everything, it just kind of goes, hold it, from a developmental perspective. That is not a very long-term strategy for these organisms because there's only so far you can hold it and like slow down development. But that's another tactic as well. There, the ovaries aren't going to be shriveling down, but it will be for those feeding effects. And again, can come right back on pretty quickly. There we go. But yeah, Golganak, the pathway is actually very amazing of how it even works. So like for the different checkpoints, it goes through different signaling molecules, but you start off with one of them, it's being insulin, and then you go like there's pathway upon pathway of different components that are then turned off or turned on. So like flathead arrows mean turned off, and then front head arrows mean turned on, and it's a whole. Barty, how the heck are you doing, my friend? I hope you're doing well. We're talking a little bit about insulin signaling and embryogenesis of fruit flies, which is, I know, a little bit crazy, but we're having fun with it. So I'm doing all right, Barty. I'm doing all right. Well, so Tiffany, we were talking about, this whole came up because we were looking under the microscope at this fruit fly, preserved in amber, 30 million years old. And you can see it's laying eggs. And we were talking about how it has a really big abdomen. And that's actually a way you can see that it is very healthy. It's a very, very healthy individual. Big catch with this organism is that its ovaries are responsive to the environment. So they have unlimited number of eggs, essentially, for all intents and purposes, and the 2-week lifespan that it has. Typical embryogenesis chat. Typical chat. And so we can look at her ovaries, and depending on what stage it is in development, you can see if she's well fed or not. So you have the original embryonic stem cells on one end. Those divide asymmetrically, meaning one cell divides and stays as a stem cell. The new cell division becomes the egg that'll go into this conveyor belt here to be laid as a fruit fly egg. Bless you, Barty.
Sorry.
No, sorry. How much to stall reproduction? How far can we go chemically or hormonally? You mean, Golganak, can we artificially do it? We can. So if you go in this pathway that I was building up, there is the last one here is let's see, I think it's Dryce, DCP. No, what is this? This is a Cas9 that's inhibited by DIAP1. Oh, and this, yeah. So DIAP1 inhibits this, and then this is DCP1. That's Cas-based. So these are like the molecules that are doing like the actual like final end business. Oh, what do you mean, Golganak? Tell me. Tiffany, we're also working on some gargoyle art today. We're adding to the gargoyles. So it's Wednesday. We haven't started yet. We've been doing science chat. Her different hormones tell her body to where to cut off. I see, Golganak, in terms of reproduction. So these two checkpoints, the same signaling pathway hits both of those at the same time. There is another pathway. So this one that we're drawing at that goes from insulin, this one will hit both stage 7 and 8 and stage 2 to 3. Thank you. There's another one though. That's stage 7 and 8. So that later egg stage, those can be shut down independently of the stage 2, 3, but it needs the right stimulus. So one starts with insulin. This one also ends in DCP1, which is the Cas base that blows up the ovaries, apoptosis. We know this one starts with insulin signaling in the hemolymph for the blood. So I'll just put blood for the sake of ease. This other one starts in the brain with a neuropeptide called NPF. And when NPF levels go down, it starts this whole thing. But everything in between here, Golganak, we don't know. So like we're here, I can tell you all the components that are in the pathway, and we could list them out and actually figure out what they are. These here, we don't know. We just know the end product is still DCP1. That's the effector Cas base that can actually destroy the ovary. And then we know NPF levels at the very top need to start going down, but everything else in between, no idea. And then what I didn't tell you, Golganak, to add further confusion on top of everything, there's also apoptosis in the stage 10 egg chamber. So the stage 10 egg chamber, oh my goodness, more along this size, right? Like for sake of argument, so we'll put in, and then there's the bigger one here. So a little more reproductive. There are a couple of nuclei inside a late stage developing embryo. There is a really big one, and then there are 13 smaller ones. I'm not going to draw out all of them, but there's 13 of these smaller ones total. 14 altogether. When it starts, they're all the same size. Here's the catch. Jern, give me 1 second. 1 second. We will get to Rise of Power. In just 1 second. I just want to go over this particular topic because 14 nuclei to start with. They're all the same size. Any one of those nuclei can become the egg. But what happens is, so these 14 nuclei, any one of the 14 nuclei can become the egg. It's randomly selected on which one becomes the egg. At this stage 10 point in development, what happens is ring canals form. which means little tubes interconnecting all these cells.